Hello, today we will discuss requirements associated to software quality. So why are requirements so essential for software quality? Where the requirements come from, different properties of requirements, and different quality models, and the requirements that are included in these quality models. So in the previous lessons we have defined quality as conformance to requirements, and for complex processes such as software development we also need to include processes. So quality is integration of product requirements and processes. For example, this means that quality is relative. The same product in different environments, so in environments involving different requirements, may have different quality estimations. So requirements which are defined as need or expectation that is stated, generally implied, or obligatory. These are essential components of quality. They actually determine quality both together with the product and the processes. So that's the main reason why requirements are so important for software quality. We might ask that why bother about requirements when they anyway change during development, and in agile development the requirements are in constant modification, and this leads to better customer satisfaction. But we need to know at least the main requirements quite early to have the business perspective, for example on cost, duration, team, and so on. We need to state some basic requirements in contracts, because otherwise it's not known what we are developing or what we have agreed. Good requirements help to avoid vendor lock-in possibility, and some especially non-functional requirements may be very expensive. For example, requirements that refer to availability or efficiency or security may increase, well, high requirements may increase and low requirements may decrease the cost of system very significantly. So we need to know at least the main requirements and state them in a correct way. So where do the requirements come from? First, of course, they come from the contracts, from the purchases, from users, from maintainers. These are direct requirements for this product agreed between the customer and the supplier. Then broad classes of requirements are stated in standards. Just as in construction development, we cannot include all construction knowledge into our contract with the construction company. Instead we refer to construction standards. The same applies to ICT. There are many usual requirements that we even don't think of typically, and only in conflicts we need to know that these are actually the requirements that are need to be kept. Finally, requirements come from laws, norms, good customs, custom ethics, and so on. So as a summary, there are many sources of requirements, and if we can establish or refer to the requirements in some formal documents such as standards, we save ourselves a lot of effort and defend ourselves against many misunderstandings. Well, let's see what kind of requirements are possible. There are actually many different requirement types, and on this picture we saw first our target software. So this is the software which we are talking about in the first case, when I talk about software requirements. But the customer is not just interested in only the target software. That customer is interested in the system that the customer is using. So the target software is associated with the product quality, and we will see a product quality model in a few minutes. But besides that, the customer is also interested in quality in use. And quality in use refers to the system, and system includes many components. On this picture we see communications, hardware, non-target software, target data, non-target data, possibly also other items. So quality in use refers to overall quality of the system, which includes also target software. Then we have data quality, and data quality refers mainly to the target data, but also in many cases to non-target data, so which are taken from other sources, not just data that refers to our target software. And we have many users, many kinds of users, the final users, administrators, maintainers, developers. Other systems may use our system. So we can look at these quality issues from the users of from the viewpoints of many different users. And if we now look at processes, how the processes evolve, then we introduce time, and we see this software and system and their quality as dependent on time, moving in time. So these are the main aspects of quality: product quality, quality in use, data quality, and process quality. We will not address process quality today. This is the next topic. Now, before proceeding to discussing some quality models, let's discuss some properties of requirements. First, we have functional and non-functional requirements. And functional requirements refer to what the system needs to do. For example, the system must input data, check data, output reports, process data, and so on. There are also non-functional requirements that state how this should be done. So, for example, requirements on efficiency, on security, and many others. I will look at these soon. Now the second question is whether our criteria or requirements are testable or not. And the easy criterion is that it should be possible to evaluate whether the actual results conform to expected results. So if a requirement is testable, we should be able to create a test, and looking at the test results should be able to tell whether these results were correct or not. Let's take an example. The system must be reliable. Suppose we now put the system on the test. We detect 2 errors in 1 week. Does this system conform to this requirement? The system must be reliable. We cannot say, because we don't have enough data in this requirement. So these general type requirements, the system must be reliable or efficient or whatever, these are usually non-testable, and as non-testable they are quite useless. You cannot use them for testing, for understanding whether the system conforms to what is needed or not. Here are some other examples. System must output the user report in the format defined somewhere. This obviously is testable. We can execute the system and see whether it outputs the user report. Second example, system must respond to user queries. This is very vague, and perhaps we could test that it responds, but it's a little value both to the customer and the developer, because they don't get any information whether the response itself is correct or not. Well, if we take this total duration of unplanned system outages must not exceed 2 hours during a 2 months period, this is seems a better thing. So it involves some clear criteria to deciding whether this requirement is fulfilled or if it's not fulfilled. But here is a caveat here too, because it doesn't say anything about in what conditions this duration of system outages must not exceed 2 hours during a 2 months period. So if somebody switches off the system completely, then it obviously cannot fulfill its tasks. And we need to say something about the environment, which takes us to the next topic, which is realistic and unrealistic requirements. Let's discuss some examples. The system must work with the following browsers. It gives some list of browsers. We can test these. If we don't have the version stated, then this may be quite difficult, even unrealistic. But the next version, the system must work with all widespread browsers. This is clearly unrealistic, because it's very difficult to fulfill, because even we don't know what are the widespread browsers. This should be agreed between the customer and supplier. With respect to these unrealistic requirements, we might ask whose risks are these. So who is happy and who is unhappy with these requirements? And with this must work with all widespread browsers. It's easy to see that the customer may be happy, or it doesn't mean too much for the customer, but the supplier has difficulties here, so it's supplier's risk. For the second example, for the next example, the system response time must be under 3 seconds. Think about whether this requirement is realistic or not, what is underspecified, how this should be improved, and whose risk is that. Now, another important topic is that software quality requirements must be traceable to stakeholder requirements. We know many examples from practical software projects where the stakeholder had some needs or requirements to the system. These needs or requirements were translated into software analysis. The customer who didn't understand the results of the software analysis signed the software analysis document and received an inadequate system which actually didn't fulfill these initial requirements of the stakeholder. To avoid these kind of conflicts, it's useful to require that we state the stakeholder requirements before stating any system requirements or software requirements. And then the quality requirements must be traceable to stakeholder requirements, and the system must first of all satisfy the stakeholder requirements. So these were some desirable properties of requirements. They should be testable, realistic, traceable. Let's now have a look at some quality models and quality characteristics. There can be potentially a huge number of quality characteristics that can be expressed as software requirements. Due to this large number of requirement types, these characteristics are often represented as hierarchy, and this is used also in ISO IC 25000 series, which we discuss today. It's important to notice that we do not need to use all these requirements from these standards. Rather, we should use them as a checklist, select those characteristics that are needed for the task, and leave the others. But it is important that we don't forget anything important, because as we already discussed earlier, some kinds of requirements may be very, very expensive from the overall product viewpoint. So here is an example of a quality model from ISO 25000 series. First we have quality characteristics. On the highest level, the characteristics have sub-characteristics, and we have attributes or metrics that refer to these sub-characteristics. For this standard, the main characteristics follow the following logic. We use software for our work. We need to modify it. We need to modify it, and we need to transfer it to new environments. For work, the main characteristics are functional suitability, efficiency, usability, reliability, and security. For modification, we need maintainability, and for new environments, we need compatibility and portability. So the overall product quality model from ISO 25010 looks as follows. We have these different quality characteristics, and each of these has their sub-characteristics. For example, for the functional suitability, we have functional completeness, which says that all the functions must be present, and we have functional correctness, which says that they must be fulfilled in a correct way. For example, if some results are computed, then what is the number of decimal places after comma, and so on. So this was the product quality model. We have the quality model for quality news in the same standard, which says that the system must be effective for the user. The user should be able to achieve her results with the system. It must be efficient. The results should be achieved with reasonable effort. The user should be satisfied. Well, usefulness, trust, pleasure, and comfort. The system must not be very risky for the user, so no bad consequences. And the system must function within the specified limits, and also, if possible, be functioning outside these limits. Finally, the data quality model characteristics from ISO 25012 include inherent characteristics, so specific to data itself. Some characteristics are both inherent and system dependent, and some characteristics are mostly system dependent. For example, accuracy refers to the data. When data are accurate or not, this doesn't depend on the system. Accessibility may depend on data and the system, and availability depends purely on the system. So thanks for listening. Here are some references to additional reading. The materials are available from Moodle. Course name is Software Quality, Tarkvara Kvaliteet, and also the slides are available from Tapani.ee. Thank you, and see you in the lectures.